day, my students. Today we shall be talking about indices and its rules. And I want you to follow me. Yes, as I told you that we're going to be talking about indices and its rules. Here we have indices are powers or exponents which raise to a number or a variable, e.g. a raised to power b. Under which we have rules. Rule 1 says when we have a raised to power n times a raised to power n, that will give us a raised to power n plus n. E.g. we have 2 raised to power 2 times 2 raised to power 2. That will give us 2 raised to power 2 plus 2. The reason is that we are having the same basis. 2 here, 2 also here. So we have to take one and add up their powers. And that's what we did. And 2 plus 2 will give us 4. Meaning that we're going to multiply our base in terms of power. And that's the reason why we have this. Rule 2. Rule 2 says when we have indices being divided by each other, we're going to take one of their bases and minus and subtract their powers, and that is what we did. Example, we have 2 raised to power 4 divided by 2 raised to power 2, and that gives us 2 raised to power 4 minus 2, and that gave us 2 raised to power 2, and as a result we are having 2 times 2, which is going to give us 4. Rule 3 says that when we have any letter or number raised to power 1, is going to give us that thing. Like we have a raised to power 1 is equal to a, yes. Example, when we have 4 raised to power 1, that one is going to give us 4. So also 2 raised to power 1, that one is also going to give us 2. That is that about that rule 3. Rule 4 says whenever we have a letter like this, we have a raised to power minus 1 is equal to 1 raised to power 1 all over a raised to power 1. Meaning that this minus means 1 all over, left with a raised to power 1, and that's what we have. And don't forget concerning our rule 3 that anything raised to power 1 is that thing, and that's why we have 1 over 8. Example, we have 2 raised to power minus 1. Now this one we have 1 all over 2 raised to power 1, which is going to give us 1 over 2. Rule 5. Rule 5 says anything raised to power 0 is going to give us 1, irrespective of the magnitude. So also example 5, we have 4 raised to power 0. That's this one we have 1. Rule 6. Rule 6 says that when we have and indices also raised to power anything, is going to give us that indices with its power to be multiplied with the power we have outside, and that is why we have this. Example, we have into bracket 2 raised to power 2 close bracket raised to power 2, and that one gives us 2 raised to power 2 times 2, which is 2 raised to power 4, and as a result we are having our bases being multiplied in terms of power, and that's why we have 16. Rule 7. Rule 7 says when we have indices having the same power, it's the same thing as all those division is being identified with that the same power, and that's why we have a raised to power n all over b raised to power n is the same thing as into bracket a all over b, everything is to power n. Yes. Example, we have 2 raised to power 2 all over 3 raised to power 2. So without wasting much of time, the same thing as everything is being raised to power 2, and that's why we have this. You can still take it in. So as a result, we're having 2 raised to power 2. That one gives us 4, and 3 raised to power 2. That also gives us 9. Rule 8. Rule 8 tells us about how the root is being used. in terms of indices. Like for instance, we're having about two roots. The first one is square root and the third one is a cube root. So we have to be taking them one after the other. Like this one now, we have this is equal to into bracket a close bracket raised to power 2 close bracket raised to power 3. So example, we are having group roots, a square root of 81 and a group root of 81. Firstly, you have to take the square root. Find the square root of 81. That one will give us 9, and the cube root of 9 will give us 3. And that is how everything is being done. And I hope so far so good with the indices and the rules of indices. So by the next class, we shall talk about on how the applicability of it is very important. So thank you very much. I wish you successful.